Now, let's start to think about how muscle is going to behave under active contraction. And the way we would start studying this with our experimental setup here with muscle and then a force gauge attached to it so we can measure the force in the muscle. Here's how we would do it. Number one, let's attach some electrodes to our muscle, and then let's attach it to a really big power source. And the reason that we want the power source to be big is to make sure that the muscle is fully activated so that all of the muscle fibers are contracting as hard as they can. So we don't have to worry about that. We're just going to blast it with as much electricity as it can handle. Then we're going to measure the force that the muscle produces. And we could do that at a wide variety of muscle lengths. So we could test it at the resting length of the muscle, right? So just no tension in the muscle or anything, and then turn on the electricity, measure how much force the muscle produces. And maybe it produces this much force. Then we could stretch out the muscle a little bit. And now what would that look like? We would instead, we'd stretch out the muscle a little bit like this, which would put some tension into it, of course, but we'll subtract that off. And then do the same thing. Zap it with some electricity, measure how much force it produces. So now we've increased, maybe I should label my axis down here as length, muscle length. We've increased the length of the muscle a little bit. And maybe the amount of force looks like that. So we could do the same thing, and we could push the muscle together so it's shorter than it usually is. So maybe the muscle's real short. This is getting ahead of ourselves here, but this is maybe if the resting fibers look like this, we're just going to push that in so it's like that. Just shorter than usual. And then do the same thing. Blast the muscle with some electricity and see how much force it produces. Now, you could do this, you could imagine doing this at many, many different muscle lengths. And what you would find is this kind of behavior. You'd get a curve that kind of looks like this. And I think from my notes here, there are, notice by the way, you get to some point on the axis here where if the muscle is any shorter than this amount, it won't produce any force at all. And if if the muscle's too long, it won't produce any force at all either. So maybe my axes aren't perfectly to scale here, but that turns out to happen about 0.5 the length of the resting length, so 50% shorter and about 50% longer. So 1.5x and 0.5x, whatever the resting length of the muscle is. So you get this very characteristic curve called the force length curve. And I noted this earlier, but we have subtracted off that passive component. So the force you would measure, say, at this length would actually be maybe like this much. But we would have to keep in mind that in the previous video, we saw that there's that passive component, the stretchiness of the muscle, that is also acting. So this is a technical thing, but we just subtract that off for this part of the curve. So this is the active force production capabilities of the muscle. So something to note about this, or a few things to note about this. Number one, the maximum force happens at this length that we call the optimal length, sometimes optimal fiber length. And then as we move away from that, there's this plateau of area where we can produce more or less close to the maximum amount of force, and then force drops off precipitously as the muscle gets too short or too long. Now, understanding exactly how this happens is going to require understanding the microscopic structure of muscle, but I want to go through these properties first because this is the way that people developed intuitions about what the microscopic structure of muscles should be. Because as I mentioned in a previous video, these properties, this force length property of muscle was known far, far before people knew anything about muscle fibers and fibrils and muscle fiber overlap and actin and myosin and any of that business. People had no idea what muscles looked like at the smallest scales, but they did know that they had these macroscopic properties. And that gave some really strong evidence for what the microscopic structure of muscles must be. So this is the force length curve, and we'll talk about this quite a bit because it has very important implications for performance and rehabilitation. There's another property of muscle that I want to talk about, though, which is something called the force velocity curve, which we'll talk about in the next video.